Mercury holds the title of smallest planet in our solar system, with a diameter of just 4,880 kilometers, barely larger than Earth's moon. What makes Mercury truly bizarre is its extreme temperature swings. During the day, surface temperatures soar to nearly 430 degrees Celsius, hot enough to melt lead. Without an atmosphere to trap heat, temperatures plummet to minus 180 degrees Celsius at night. This 600-degree range is the most extreme of any planet. Mercury is also slowly dying. Its massive iron core, which makes up 85% of its radius, is cooling and contracting. As it shrinks, the surface buckles and cracks, forming enormous ridge-like cliffs called lobat scarps that stretch for hundreds of kilometers. The planet is literally collapsing in on itself, shrinking about 14 kilometers over billions of years. Perhaps most peculiar is Mercury's sodium tail. Like a comet, Mercury trails a specter of sodium gas as it orbits the sun. Solar wind strips particles from its surface, creating this faint tail that extends millions of kilometers into space. Despite being scorched by the sun, ancient water ice is found in permanently shadowed craters at Mercury's poles, frozen for billions of years in darkness. Mercury takes 88 days to orbit the sun, but rotates so slowly that one day on Mercury lasts 176 Earth days, meaning you'd experience 2 Mercury years before seeing 2 sunrises. Venus appears deceptively beautiful from space, shrouded in thick clouds that make it the brightest object in our night sky after the moon. But beneath those clouds lies the most hostile environment in the solar system. Surface temperatures average 465 degrees Celsius, hotter than Mercury despite being nearly twice as far from the sun. This heat is caused by a runaway greenhouse effect, where carbon dioxide traps heat so efficiently that it never escapes. The atmospheric pressure on Venus's surface is 92 times that of Earth, equivalent to being 900 meters underwater. This crushing pressure, combined with clouds of sulfuric acid, would dissolve any human within seconds. Soviet Venera probes that landed there in the 1970s survived barely an hour before being destroyed. The atmosphere is so dense that it scatters sunlight, making shadows appear non-existent and giving the landscape a surreal, diffuse glow. Venus rotates backward compared to most planets, so the sun rises in the west and sets in the east. Even more bizarrely, Venus's rotation is so slow that one day, 243 Earth days, is longer than its year of 225 days. Recent discoveries of phosphine gas in Venus's clouds have sparked controversy because this gas is associated with biological processes on Earth. Whether Venus once had oceans and potential life remains one of planetary science's greatest mysteries. Earth is the cosmic outlier, the only known planet with life. This makes our world precious yet vulnerable. Earth's magnetic field, generated by its liquid iron core, creates the magnetosphere that deflects deadly solar radiation and cosmic rays. Without it, the solar wind would strip away our atmosphere, as on Mars. The magnetic field is unstable and flips polarity irregularly, a process that has happened numerous times throughout history. During reversals, Earth's magnetic protection weakens, increasing radiation exposure. The surface is constantly reshaped by plate tectonics. The slow movement of crustal plates floating on the molten mantle. This activity recycles carbon, regulates climate, and forms continents and ocean basins. Earth is unique in having active plate tectonics, which may be critical for long-term habitability. The lithosphere divides into 7 major plates plus smaller ones, moving at a few centimeters per year, about as fast as fingernails grow. Earth's atmosphere is 78% nitrogen and 21% oxygen, with trace gases including carbon dioxide. Its precise composition is maintained through biological and geological processes. Oxygen is mainly produced by photosynthetic organisms. Cyanobacteria created our oxygen-rich atmosphere over 2 billion years ago during the Great Oxygenation Event. Earth also maintains a stable climate via the carbon silicate cycle, where volcanic activity releases CO2 and weathering removes it, acting as a long-term thermostat. And because Earth is orbiting at just the right distance from the sun, known as the habitable zone, liquid water can exist on the surface, making Earth a 1 in a billion cosmic miracle. Mars earned its nickname the Red Planet from iron oxide, or rust, that covers its surface, giving it a reddish hue visible from Earth. This rust indicates a watery past when Mars had a thicker atmosphere and liquid water flowed across its surface. Today, Mars is a cold desert with an average temperature of minus 60 degrees Celsius, ranging from 20 degrees Celsius at the equator during summer to minus 153 degrees Celsius at the poles in winter. Mars hosts extreme geological features. Olympus Mons is the largest volcano, standing 22 kilometers high, nearly 3 times Mount Everest's height, with a base wider than Arizona. Valles Marineris is a 4,000-kilometer-long canyon system with 7-kilometer depths spanning the entire U.S. if on Earth. These features formed because Mars lacks plate tectonics, allowing volcanic hotspots to build continuously. Mars has 2 small, irregular moons, Phobos and Deimos, likely captured asteroids from the asteroid belt. Phobos orbits so close that it completes 3 orbits per day and is spiraling inward. In about 50 million years, tidal forces could tear Phobos apart, possibly creating a temporary ring. Meanwhile, NASA's Perseverance explores Jezero Crater, an ancient lake bed. Seasonal methane fluctuations and organic molecules suggest Mars may have been habitable and might host microbes beneath its frozen surface. Jupiter is a monster among planets, more than twice as massive as all other planets combined, and 318 times more massive than Earth. This gas giant has no solid surface. It consists primarily of hydrogen and helium in various states of compression. Descending through Jupiter's atmosphere, the increasing pressure converts gaseous hydrogen into a metallic liquid that conducts electricity and generates the planet's powerful magnetic field, which is 20,000 times stronger than Earth's. Its most famous feature, the Great Red Spot, is a storm system larger than Earth that has raged for at least 350 years. Wind speeds in this anticyclonic storm reach 432 kilometers per hour. Mysteriously, the Great Red Spot is shrinking. It's reduced in size by about a third over the past century, though astronomers don't fully understand why. Jupiter's rapid rotation of just under 10 hours creates atmospheric bands and intense storm systems with lightning strikes 1,000 times more powerful than Earth. Jupiter acts as the solar system's gravitational bouncer, deflecting dangerous asteroids and comets away from the inner planets. This protective role may have been crucial for life's development on Earth by reducing catastrophic impact events. The planet has 95 known moons, including the 4 Galilean moons. Europa harbors a subsurface ocean beneath its icy shell with twice as much water as all Earth's oceans. Io is the most volcanically active body in the solar system, with hundreds of active volcanoes erupting plumes over 300 kilometers high, driven by Jupiter's immense gravitational pull. Jupiter's radiation belts are so intense they would deliver a lethal dose to any unshielded human within hours. Saturn is the solar system's showpiece, famous for its spectacular ring system, visible through small telescopes. These rings extend up to 282,000 kilometers from the planet, but are surprisingly thin, about 10 meters thick in most places. They're composed of 99% water ice mixed with rocky debris, from dust-sized particles to house-sized chunks. The rings aren't solid, but consist of countless individual pieces orbiting Saturn independently. Scientists believe they're relatively young, perhaps only 100 million years old, and possibly formed from a destroyed moon or captured comet. Saturn is a gas giant with no solid surface, mainly made of hydrogen and helium. It's the least dense planet in the solar system. It's actually less dense than water, so it would theoretically float if placed in an ocean. Like Jupiter, Saturn's interior likely contains metallic hydrogen, and it radiates more heat than it receives from the sun, suggesting internal heat generation. Its atmosphere features a unique hexagonal storm at the North Pole, a jet stream with perfectly straight sides that has persisted for decades, an unusual pattern still poorly understood. Saturn has 146 confirmed moons, with Titan being larger than Mercury and possessing a thick nitrogen atmosphere. Titan is the only moon with a substantial atmosphere and features lakes and seas of liquid methane and ethane, the only such surface liquids besides Earth. Beneath its thick atmosphere, extreme pressure causes carbon to rain diamonds, which may accumulate in deep liquid diamond oceans. The Cassini mission, orbiting from 2004 to 2017, revolutionized our understanding before deliberately plunging into Saturn's atmosphere to avoid contaminating moons. Uranus is the solar system's oddball, rotating on its side with an axial tilt of 98 degrees, rolling through its orbit rather than spinning upright like other planets. This tilt was probably caused by a major collision with an Earth-sized object early on, leading to extreme seasonal changes like 42 years of sunlight followed by 42 years of darkness during its 84-year orbit. Primarily composed of water, methane, and ammonia ices surrounding a rocky core, Uranus's structure differs from the gas giants Jupiter and Saturn. Its methane absorbs red light, giving it a blue-green color. Despite being closer to the sun than Neptune, it is colder with temperatures dropping to minus 224 degrees Celsius and it radiates little internal heat, possibly due to the impact that tilted it. Uranus features a faint dark ring system discovered in 1977, and 27 moons, mostly named after Shakespearean characters. Miranda's landscape includes deep canyons, fractured terrain, and patchwork regions, likely reassembled after impact. Its magnetic field is offset 59 degrees from its axis and not centered, creating a lopsided magnetosphere generated in the icy mantle. Neptune is the solar system's final sentinel, orbiting at 4.5 billion kilometers, 30 times Earth's distance. Despite receiving 900 times less sunlight, Neptune generates more internal heat than it absorbs, radiating 2.6 times as much energy as it gets. This heat source remains a mystery, possibly from gravitational compression or leftover heat from formation 4.5 billion years ago. Neptune has the fastest winds in the solar system, reaching 2,100 kilometers per hour, faster than sound. These drive massive storms, including the Great Dark Spot observed by Voyager 2 in 1989, similar to Jupiter's Great Red Spot. Unlike Jupiter's long-lived storm, Neptune's dark spots come and go over years or decades, indicating different atmospheric dynamics. Its deep blue color comes from atmospheric methane, which absorbs red light and reflects blue. Neptune has 16 moons, with Triton being the most notable. Triton is the coldest known object in the solar system, with temperatures of minus 235 degrees Celsius. It orbits Neptune backwards, evidence it was captured from the Kuiper Belt rather than forming with Neptune. Despite its cold, Triton is geologically active, with nitrogen geysers erupting dark material up to 8 kilometers high, suggesting subsurface activity likely driven by tidal heating. Triton is slowly spiraling toward Neptune and will be torn apart by tidal forces in about 3.6 billion years, possibly forming a spectacular ring, perhaps even surpassing Saturn's. From Mercury's ice-filled craters to Neptune's supersonic winds, our solar system contains worlds that challenge our understanding of planetary science. Each planet reveals how diverse geological and atmospheric processes can create radically different environments from the same primordial material. The more we explore, the more questions emerge. From Venus's possible ancient oceans to the subsurface seas of Jupiter's moons that might support life. These 8 planets, formed from the same solar nebula 4.6 billion years ago, demonstrate that planetary evolution follows complex paths shaped by distance from the sun, initial composition, impacts, and countless other variables. As our telescopes discover thousands of exoplanets around distant stars, our solar system provides the only detailed laboratory where we can study these processes up close, making each mission to our neighboring worlds essential for understanding planets throughout the universe. If you're fascinated by the universe's most extreme environments and bizarre planetary phenomena, make sure to subscribe. We've got more cosmic mysteries coming your way. Check out this video next. Thanks for watching.